In this section, we're going to look at a new type of regression called exponential regression. This is used when you believe that the data points that you're gathering fit an exponential model rather than a linear model. And that happens with many naturally occurring phenomena. For example, the spread of disease is an exponential phenomenon. What I'm going to do is I'm going to demonstrate plugging our points into Desmos, and then we will fit it with an exponential model rather than a linear model. Alright, so here is my table in Desmos. I want to just copy the sets of points that I have to create the same scatter plot that we see there. I'll rescale my axes. Okay, that's better. Now we see an upward trend for the data. And in the past, what we would have done is we would have fitted this with a linear model using the formula y1 tilde mx1 plus b. And it's not necessarily wrong to do that. Okay, there is definitely an upward trend here. But now that we're aware of the exponential function, we can see that there's a curvature to this. And so oftentimes you have to let the data inform what type of regression curve is best. In this case, I feel that an exponential model would be better than a linear model. So let's get rid of this. And instead, we'll type in y1 tilde a b to the power of x1. What this does is it creates two constants, a and b, and the variables are, of course, y and x. Now, if you just have b to the x, it's not quite as good a fit. But if we multiply by some constant a here, we can fit it even better. Now, the TI-83 and 84 calculators can do exponential regression as well. However, the TI-30X2S is not advanced enough to do exponential regression. The TI-83 and 84 calculators, if you have it, will actually be using what is called log mode to get their constants. So we want to actually check that here in Desmos as well. It's just two different methods of calculating exponential regression. And now we can gather our A and B constants from the program, and we can write them down to create the best fit mathematical model. So A equals 3.05 and B equals 1.99. Then what we do is we replace the A and the B in the formula like this. And that is our exponential regression model. The next page will discuss the steps for doing this exponential regression on Desmos.com or the TI-84 Plus CE calculator.